All right, here we go. We got a whole fresh unit now. This is going to be called Unit 2. And the big picture, what we're going to be doing is radicals, square roots, cube roots, all that kind of stuff. We're going to start really digging into that, graphing, looking at different functions related to square roots and other roots. This first lesson is related to that, but it won't seem like it at first because it's called rational exponents. Rational means fraction, and exponents are powers. So we're going to have powers that are fractions. And let's take a look. So the first thing I have for you, which I normally don't do, I want to give you a couple rules that you can write down as you're watching this video, and then you can refer to them as I'm doing different problems along the way. From what I can see, I think we're only going to need basically 2 rules today. One of them, which is the lesson right here, which is that if you have an exponent that's a fraction, so you have something to a power, but the power is a fraction, you can rewrite that as a radical. That's why it fits into this unit. This whole unit's going to be on radicals, on these guys right here. See? And the way it works is the denominator of that exponent, that fraction exponent, becomes the root. The base, the thing you're taking the power of, goes inside of the radical, and the numerator is the power on the outside. And it just works out mathematically that this power on the outside could also go here. So I put an or there. Notice everything else is the same. It's the denominator always becomes the root, the base becomes the inside of the radical, and the numerator can either be written on, you can put a big parenthesis around it to the power of that, or that thing could go inside of there. Those are going to mean, if you put it here or here, it doesn't change anything mathematically. The second rule, something you've seen tons in Algebra 1, 2, and that's that if you have the same, if you're going to multiply 2 things together and they have the same base, then you just add the exponents together. We're going to see that show up. I mean, that's just like saying, like here's an example. If you had, it's kind of an obvious rule. If you had this, doesn't that mean x times x times x times x times x? So how many times did I multiply x? It was 5 times, right? X times x times x times x times x. So it's x to the 5th, and the rule is you just add the exponents in that case. All right, let's look at some new type. I got 3 on a page here because there's really no work to these at the beginning. It's just if you have a fractional exponent, it really is this simple. We're going to immediately, it says write it in radical form. So we're going to put a radical there. We're going to put the denominator as the root. We put this becomes the inside of the radical. And then this numerator can either go right here, or you could make a big parenthesis and put it on the outside. Either way, let's just go with this method for now. Next one, if there's same thing, if it's a fractional, if the exponent is a fraction, you can always write it as a radical instead. The x goes inside. The denominator, 2, would go here. But that's the one number we don't write. When we're taking a square root, we don't write the 2 there. It's just implied. Square root doesn't write the number. If it's any higher root, then we have to put the number. Like up here we had a 3. So in this case, that 2 is there, but we don't write it. And then the first power, we could put that there. That doesn't do anything either. Or in other words, anything to the power of half is basically just square root. It's the same thing. Half power, square root, same exact thing. And then this one here, it's a radical. You can put the 2a, the whole, whatever's in parentheses here to the power, that whole thing goes inside. The denominator goes here, but once again it's a 2, so we don't write that. And then the numerator would go here. Pause it if you need to. That's the key to this whole lesson, is those basic rules right there. These next three are just the opposite. So same rule, we're just working in a backwards direction. We're starting with the radical, and it says write in exponential form. So we're just doing everything backwards. So this first one here is basically just a square root. Square root is half power, just like you just saw in the last one. It means half power. So it's 3x, put it in parentheses, to the half power. If you think about it, read it backwards now. Remember that the whatever's here goes inside. This number here, the denominator, becomes the root, but it was just a square root because it didn't have the number written there. That's always a 2. And then it's to the first, there was just no power here, so we put a 1 there because it was a first power. Do it again. It's going to be 2p in parentheses to the 1/6 power. Once again, the root becomes the denominator. There is no power on the outside on this one, so we just put it as a first power. That's what power that is. Next one is going to be 2x in parentheses, and then it's a square root again. There's no number there. That's always a 2. And then the power on the outside is 3. So if we're writing our fraction, here's the fraction bar. There's the fraction bar right there. Remember, this number becomes the denominator, and this number is the numerator. Denominator, numerator. That's it. This first lesson is just some real basic skills, some things you've talked about in previous classes, maybe a little bit you haven't, but it's just getting us started. Here's a couple more. So what's going on now, same rules, nothing's really changing except we don't have any variables. So now it says simplify, meaning there's an answer now, a math number answer to this problem. So we're going to finish it the best we can. Step 1, write it as a radical. The 81 goes inside. The denominator becomes the root, and the numerator becomes the power on the outside. You notice, I guess we could put a parenthesis around that, okay? And you notice I'm not going to write that 2 there because that's a square root. If it was any number but a 2, I would write the number there. Now we're not done with this one. We're not done because this is an actual numerical problem that we can finish. If this just had x's in it or whatever, we would just stop right there because there's really nothing to calculate. But here we know the square root of 81 is 9. So this is equal to 9 to the 3rd power. And then whatever that is, we can actually finish it with an actual number. 9 times 9 times 9. Which is 729. Hey, first time I needed a calculator in this class to do that. Next one. This is just going to be 64 inside the radical. The denominator becomes the root, so now we are going to write that little 3 there. And then the first power, the numerator is a 1. We don't really need to write a 1 there, so we'll just leave it like that. And now we have to ask ourselves, what number, remember this is still just numbers, so we can finish the problem. We can have an answer to the problem, just like we had a 729 here. This is a radical cubed root. It's saying what number multiplied 3 times together, the same number, would equal 64. And you know, the calculators will do that for you, or you can just kind of think about it. It turns out it's 4 times 4 times 4. If you multiply 4 3 times, you'll get 64. So the answer is 4. And one more example for you. This example incorporates a couple things. I saw a few of these like in the homework, so I wanted to help you out. First thing you got to remember is that when you have two things, this is a rational exponent times another rational exponent, then we add those exponents together because these match. So you start with that, and that would just be, you got 3 over 2 plus 1 over 2 is 4 over 2. But 4 over 2 is 2. and that's it. Of course, on this problem, you can't go any further because we don't really know what x is. If this was a number, we would then finish the problem with a numerical answer. But in this case, it's just a variable squared. It's x squared. We're done. We've done the best we can. Question said simplify. It used to look like this. We made it look a little cleaner. We did our job. Short, quick lesson there. The homework will feel the same. It's going to be nice, short, quick homework for you. We'll build off of this though, so don't let it slide. As easy as it is, make sure you're very comfortable with the fact of what a rational exponent does. The numerator, denominator, how this always becomes a radical if you want it to. In this problem, this was the only example where we didn't need to have a radical because when you added these two numbers together, you ended up with just a whole number. And therefore, it's not a radical because it's not a fraction. But all those other examples, it's all about fractional exponents today. All right, work hard, be nice, see you soon.